All right, on tonight's episode of Python Papi, we're back inside our generative AI course, and we're still going over our vector databases with Pinecone. Let's have a look at what we went over tonight. Now, last night, if you recall, the last thing we did was actually create embeddings for each of the chunks that we have, and this is how we did that here with the doc search equals pinecone dot from text. Now, after we run that particular line of code, we will generate an embedding. Now we can go back to the Pinecone dashboard and check all the embeddings. The embeddings will be in the first row. The text we tokenized are there also. Let me take this T off because it's not 10, it's N. The embeddings are the values in the first row. The text gets converted into embeddings, which gets converted into vectors. And this is also a similarity score. There's also a similarity score inside that first row. So inside that first row, we're going to have some text, we're going to have some values, and we're going to have a similarity score. Now, the similarity score indicates how similar this sentence is to other sentences or phrases. And we can also access the embeddings by calling doc search like this. You can see here we have doc search. We just call it doc search, and it actually give us the same information. Now, next we will look at an example of a similarity search. We can do that by performing a query like this first. So we're going to query, and then we're going to have our a Game of Thrones book one outperforms which models. Next we will find out the similarity. Next we will find out the similarity search. We can do that like this. So we're going to go ahead and move forward, and we're going to do docs equals dot search similarity search query. Notice we called our similarity search and passing a query as our parameter. Now we can run this similarity search by calling dot like this. So we have docs. It's supposed to be dots, not dot. So we can just call docs and that'll run our docs search similarity search query. Now we're going to actually now running it like this will turn our similarity search in the form of vectors. So it is not required or it is not returning proper sentences like this. So when we run it just like this, it's going to come back in vectors or as numbers. It's not going to come back as sentences. Now we will go over the steps of converting these vectors, numbers, into sentences. For this, we need to create an LLM. Now this means we need to call the OpenAI API. First, we have our OpenAI method, which we'll create an object of, and this is how we're going to do that. LLM equals OpenAI. Now, I'm not going to go any further because I stopped it right there. As you recall, we don't have access to the OpenAI API. We have access to it, but we're not subscribed to it, so it's not going to do anything running it for us. But I just want to still go over the steps so when we do get to the open sources like Huggy Face, we can still use these steps to do exactly what we need to do using the Pinecone. But of course, I will keep you posted every step of the way. Let me move down and see what else we had, just in case. Yeah, we did a few more steps. Like I said, though, it doesn't really matter going. It does matter, but it doesn't really do anything going over them because we can't run it, which were the next steps. So I can show you exactly what was going on, like the instructor ran for us. Like I said, we don't have access to the OpenAI API, so just telling you about it wouldn't do any justice as to you actually seeing it. But of course, like I said, I'm going to keep taking notes until we get to the open source models like Huggy Face, where we can use these same steps and we can implement these same things that we need to implement to use Pinecone vector databases. Of course, we will keep moving forward, and I will keep you posted every step of the way. But for now, this is the Python Poppy. You guys stay Gucci.